All right, welcome back. We are to the final section in chapter 4. These are going to seem a little weird and understandably. What we're going to do is we're going to do quadratic inequalities. And to solve these, we're going to end up with intervals of numbers as we do this. And this is basically telling us where is the function positive, where is it negative, meaning when is it above the x-axis and when is it below the x-axis. Let's start with a up here. First thing I have to do is get the whole thing to 0. So x squared minus 5x minus 6 is less than 0. Next thing is I'm going to factor this. So this will be x minus 6 and x plus 1. And what's going to happen is I need to get what are called critical values. And those are going to be the values of x that are going to make this equal to 0. Now, can you see that x equals 6 is going to be 0 and x equals negative 1? And what we're doing with this is we are going to come up with a way to check where we're negative and where we're positive. So I'm going to put negative 1 here, 6 here. And I'm going to break this up in kind of partitions, as it were. And I'm going to choose a value of x to the left of negative 1. So let's say x equals negative 2, and plug them into here. And the point is, not that we got an 8, the point is that we got a positive value. Now let's pick something between negative 1 and 6. The easiest one, I think, is x equals 0. So now I'm going to plug 0 into here. 0 minus 6. So that's negative 6 times 1, which is negative 6. And once again, the important part there is that we got a negative value. Something bigger than 6, let's pick 7. 7 minus 6, 7 plus 1. That's going to be 1 times 8, which is 8. And once again, we're looking at the sign here. So in actuality, what's happening here, and for this one, we want to know when it's negative. So that's going to be this middle part here. So the answer is actually going to be between negative 1 and 6 is my actual answer. Let's get an idea of what we mean by this. So the parabola is going to be like this. And you can see it's positive, it's above the x-axis from negative infinity to negative 1, and from 6 to infinity, it's above the x-axis, and it's below the x-axis here. Let's do part B. So I'm going to move everything over. So this is going to be negative 2x squared plus 11x minus 15 is bigger than or equal to 0. I'm also going to divide through by a negative 1. Now remember, when you divide an inequality by a negative, it switches the direction of the inequality. So negative 1, 1, 1. We end up with 2x squared minus 11x plus 15 is less than or equal to 0. So I'm going to get my critical values now. So this factors into 2x minus 5 and x minus 3. So critical values are going to be at x equals, it's going to be 5 halves, or 2.5, we'll say, 2.5, and at 3. So we have a very small window here. So this 2.5 and 3 are very close to each other. I'll exaggerate a little bit so we have some room to work with. I'm going to plug in 0. That's way over here. When x equals 0, I get negative 5 times negative 3. That's going to become a positive 15. And in reality, because this one's going to be a positive. When we have a quadratic, they do alternate. And we again want to know when it's negative between 2.5. And we also have the equal there, so we're going to use brackets. Notice this previous one, we didn't have the equal symbol, so we had to use parentheses here. Because we have the equal symbol here, we're going to include the endpoints. Let's take, mine says I skip C and go to D, but yours will say C. All right, so we have x squared minus 5 is bigger than or equal to 0. Well, this is going to factor into x minus root 5, x plus root 5, bigger than or equal to 0. So my critical values are at x equals plus or minus root 5, which is about 2.2 and change. Let me show you where I'm getting that from. Square root of 5, about 2.2. So that would be a good marker for us. So here, our critical values of negative root 5, positive root 5. And let's test 0. That's going to be negative root 5 times positive root 5. That's going to be negative. So once again, the pattern seems to be. This only works for quadratics when they're like this. So don't automatically think that it's always going to be alternating. There are other functions where that does not happen. And they want to know where it's positive and including the endpoint. So this is going to be look like this. Let's get it here. So this is going to be negative infinity to negative root 5, inclusive, because the equal symbol, then root 5 to infinity. Box our answers. All right. E is going to take a little bit of doing. All right, E. So we have x squared minus 4x minus 7 is bigger than 0. Now, here's why it gets tricky. We have to use the quadratic formula. This one doesn't factor, unfortunately. So let's see what we get. See what we can go with that. 4 plus or minus the square root of 16 plus 28. 2, 4 plus or minus. See, that's going to be 44, it looks like to me. Which simplifies. You can get a 2 out of that. That'd be left with 11 there. Factor the 2 out, that's going to give me 2 plus or minus root 11, it looks like. And let's see what we can get from that. So these are my critical values here. So 2 minus root 11, 2 plus root 11. And let's get an approximation for those. So 2 minus root 11, negative 1.3. Okay, so 0 is between here. So let's test 0 real quick. 0 is going to give me a negative. So once again, negative in the middle, positive, positive. And we'll note we are not including the endpoints on this one. There's no equals there. And we want positive, so this is going to be negative infinity to 2 minus root 11, parentheses, 2 plus root 11 to infinity. And let's get F. 25x squared minus 40x plus 16 is less than 0. And this factors into 5x minus 4 squared. Here's what this graph actually looks like. If we go to, so the critical value is at x equals 4/5 or 0.8. And this graph is going to do this. So this is going to be 4/5. And the graph is going to do this. It's going to come here and it's going to bounce right off. So this thing is never negative, right? It's squared. It's always positive. So in this case, this will never be less than 0. Yep. Not too bad. These just take a little bit of practice.